Welcome back, everyone, to the Knowledge Graph Forum. I'm happy to present Sarah, who's the Client Service Director at Synaptica, one of the Ontotext partners. The floor is yours, Sarah.
Good afternoon, everyone, and thank you so much for joining me today. It's really a pleasure to be presenting to you on Graphite Knowledge Studio, which is a Synaptica product that's built on Ontotext technology for the benefit of our customers that have automated content classification needs. Today, I'll be walking you through a few topics. First, I will briefly introduce you to Graphite Knowledge Studio, which is the product that combines the powers of information science and data science to meet real customer needs. From there, I'll walk you through in more detail the principles and processes that underlie Graphite Knowledge Studio, including critical workflows to support human-in-the-loop reviewers. And finally, we'll talk about the value of the knowledge graph for this end-to-end process. I'll begin first, actually, by taking a step back. And I want to talk a little bit about what content classification looks like today for our customers. And I'm just going to pause for a moment. I'm having a little bit of a technical problem, and then we will pick it back up. So excuse me. Sorry, Ivan. Okay, sorry, everyone. I think I'm back. Before I go any farther, I just want to orient you to the current state of content classification for many of our customers. These customers generally have large stores of enterprise content, which they really want to use for maximum effect. This requires them to understand at scale what that content is about so that relevant and complete content sets can then be surfaced internally or externally, whether that's through search, filters, recommendations, or some other method. So what do I mean by content classification? First, there's tagging, identifying the many concepts or named entities in a document. Then there's categorizing, which is identifying the few concepts or named entities that a document is truly about. And finally, there's extraction, which allows you to identify new concepts or named entities that exist in a document, but which might not yet exist in the enterprise's tagging vocabulary. Without machine labeling and auto-categorization, what does tagging look like today for most enterprises? Well, generally, an approved set of concept labels or tags are defined and organized into enterprise taxonomies, which are designed and stored in some type of single source of truth. We always recommend that this be in taxonomy management software, though for some organizations, this is SharePoint or an Excel spreadsheet. Wherever it lives, the taxonomy concepts are then exposed to human reviewers who tag individual documents with the relevant concepts. One of the first things that our customers realize when they begin auto-categorization is that the human benchmarks that are really meant to represent the gold standard aren't actually all that accurate or complete. There are frequently two models for human tagging, and each has their own benefits and costs. The first is represented on the left in this image. A subject matter expert who knows the content well applies the tags to a document. These employees are completing tagging as a side request, not core to their job, and it's a task that takes them away from higher priority or higher value work. They may be distracted or rushed or simply just not take the job very seriously. And we find that these reviewers will generally provide accurate but incomplete categorizing tags. In the second model, represented on the right, a non-expert human is applying the tags. Their tagging may be their only job, such as in offshore content labelers, or it may be a part of their core job, which includes uploading content to a website. They aren't familiar with the content, and they have to quickly scan the document and review the taxonomy to try to select the appropriate tags. Because they lack familiarity and expertise with the document, they will frequently select incorrect tags, and they will also be incomplete in their categorizing, as with the expert reviewer. With either group, document tagging, and by that I mean selecting all the concepts or named entities that a document contains, has even worse performance. Especially with long documents, a human reviewer will not find all mentions of concepts, products, and services in a document, especially in most organizational workflows as I've described them. An extraction of new entities will also be really haphazard. A human reviewer might notice that they can't find a topic which is relevant for the document, but they usually only take the next step if they really need it or are really passionate about the topic. Otherwise, they select the nearest relevant topic and move on without reporting to the taxonomy team that a concept is missing. So to summarize, what our customers usually learn quite quickly from an auto-categorization project is that their human benchmarks aren't particularly high quality. And this lower quality data has only been achieved by pulling skilled experts away from their core work or investing in large content labeling teams, either in-house or offshore. So this is clearly a system that's ripe for disruption. And this is where Graphite Knowledge Studio comes into play. Graphite Knowledge Studio is built on top of Ontotext technology, specifically Metadata Studio, GraphDB, and the Text Analytics Service. It combines the power of data science at scale with the controlled vocabularies and human curation of information science. And together, taken together, these technologies allow our customers to begin to, at machine scale, tag, categorize, extract, and power similarity and discovery. And the best part of the product is an ever-improving feedback loop led by a human in the loop. I'm displaying here the basic workflow of Graphite Knowledge Studio. It begins with taxonomists or content strategists designing schema and curating taxonomies or controlled vocabularies to describe their enterprise content. Text Analytics Services then annotate enterprise content with the concepts or named entities from the taxonomies. These annotations can then be reviewed by the taxonomy or content strategist who can iteratively write categorization rules that improve the annotations on the document. This is because the annotations are transparent and explainable to human reviewers who can enrich their taxonomies with these rules and improve the quality of annotations. Across the process in this top row, the human in the loop can evaluate Corpora with standard metrics to measure the ever-improving correlation of machine tagging to human understanding. And with some tuning, Text Analytics Services can also extract new entities or concepts not currently present in the taxonomy, which can then be considered by the human in the loop for addition to the taxonomies. So across this top line, the process allows the human in the loop to iteratively review and improve both the taxonomies and the annotations of taxonomy concepts. All this annotation data is then stored in a central knowledge graph where it can power further insight and functionality. Annotations within the graph can be visualized and analyzed. They can drive similarity indexing, which can power recommendations. And all the knowledge graph data can be exposed in consuming systems and generally automate categorization pipelines. This process can empower non-engineering and non-data scientist colleagues in driving large-scale document tagging and auto-categorization, while also facilitating the improvement of enterprise taxonomy design. This methodology is, of course, powered by enterprise taxonomies. So how does that taxonomy to annotation process actually work? Let me begin by orienting you to how enterprise taxonomies are typically used today, as well as how your enterprise SCOS taxonomies can be enriched and extended to power auto-categorization. Taxonomies typically represent the collective organizational knowledge about the enterprise's content, products, and services. They're often built up over years to reflect the ways in which an enterprise thinks about their domain. They generally offer much more controlled and precise definitions of concepts and named entities than LLMs or machine learning algorithms are able to employ. But they do require intensive human effort to design and maintain, and they are very challenging to deploy at scale, as you've seen in the example of human tagging. Luckily, SCOS taxonomies can be easily extended to power auto-categorization, harnessing all of this human knowledge, but scaling in a way where machines excel. How is this achieved? It all relies on the SCOS data model. SCOS is the W3C standard or semantic web standard for taxonomies, which allows these taxonomies to be machine readable and also storable in a graph. It has specified standard fields, but also a method for expanding with custom properties. Standard SCOS properties for preferred labels and alternative labels are really well suited to standard NLP root string matching techniques. And these fields, preferred labels and alternative labels, can be evolved or enriched during the auto-categorization process to make them even more effective for these purposes. In many cases, it may require introducing for the first time alternative labels or expanding alternative labels to reflect greater context. The hierarchies of SCOS taxonomies are machine readable, which allows the text analytics service to power the inference of broader topics from narrower topics, or perhaps from other relational inference. And with SCOS, distinct schemes can be managed in parallel. So you can identify one specific scheme for tagging and another for categorizing, or you could indicate to the tagger to use taxonomies A, B, and C against one corpus, but a different set of taxonomies, B, D, and E, against another corpus, and so on. But this is about as far as standard SCOS goes. Luckily, we can extend SCOS schemes with custom properties, and this extension of SCOS can really supercharge auto-categorization and tagging based on enterprise taxonomies. Some of the extended properties that are key are listed here in the dark purple on the slide. You can use custom properties to define contextual clues for the tagger. You can write must match or must not match rules either in natural language or through very tightly defined regular expressions. And you can introduce additional properties that influence how the relevance scores are actually calculated by the tagging service when they generate categorization tags. But the quality of this process really comes from having a knowledgeable, critical human in the loop. Someone who's reviewing the annotations, critically evaluating performance, iterating on the taxonomy design or enrichment or tagging rules, and then re-reviewing the tagger performance. Let me walk you through how this works in a little bit more detail. So on the slide, you see an example of an annotated document. On the left, you'll see multiple colored boxes. Each color represents a different taxonomy or scheme that has been activated for annotation on this particular corpus of documents. Each individual box represents a single annotation created by the tagger to categorize the document. That is, to identify the few topics that this document is truly about. And the tagger has assigned a score to each, which represents the confidence level of the document level annotation. On the right, you can also see the work of the tagger in line. Each underline indicates a concept identified by the tagger. A reviewing human in the loop can actually select a specific concept on the left pane, and the interface will highlight the relevant underline tags on the right that contributed to that document level classification and score. Each concept is identified as either explicit or inferred, and it links back to the full concept record in the taxonomy. It's this transparency and explainability that's really key to this approach. This is not a black box algorithm, and this allows business users to drive and manage this process without needing support from engineering and data science teams. The process of machine tagging is clear. It can be interrogated. And where there may be a gap in understanding between machine and human, this gap can be iteratively whittled down by the human in the loop through either taxonomy enrichment or rule writing. The rule writing occurs in those extended SCOS properties that I outlined previously and which you can see here on the lower right of the screenshot. And when you're working with productionized text analytics services, as you are in Graphite Knowledge Studio, the re-annotation of documents after rule writing is near instantaneous. There is no prolonged model retraining. The change in the taxonomy data that happens here in the taxonomist interface is immediately available to the text analytics service, and documents can be re-annotated in seconds or faster, and substantial corpora can be re-annotated in minutes. Let's walk through a specific but simple example to give you an illustration of how this rule writing might play out in practice. So imagine you have a concept in your taxonomy, fruit. Now, as a human, you know that fruit includes a wide array of specific fruits, bananas, strawberries, apples, etc. But when you originally designed your taxonomy, say 5 years ago, you included a definition of fruit, but you didn't think it was necessary at the time to add in specific fruit, either as children or alternative labels. The simple definition of fruit and a basic human understanding of fruit was more than sufficient for your purposes at the time. But now you're running auto-categorization, and you're realizing through this process that your design doesn't match the literature, that your content rarely uses the word fruit. Rather, your content talks a lot about oranges, apples, and pears, and the machine isn't tagging these documents as about fruit because it hasn't been taught that oranges, apples, and pears are indeed fruit. You realize that now is the time to enrich your taxonomy for the purposes of auto-categorization, so the machine can also identify documents about oranges, apples, and pears as being about fruit. You have a few choices. You could add the individual fruit concepts as children of the parent fruit, and the tagger will then infer fruit as the broader topic from the narrower topic. You can add individual fruits as alternative labels to the concept fruit, or you could write context tagging rules naming individual fruit within the concept record. Which particular strategy that you choose will be determined on how your enterprise is using your taxonomy in other use cases and also your own governance rules. But whichever you choose, the enriched taxonomy data is instantly available to the tagger. You can re-annotate the documents, and now the categorization of fruit at the document level will appear. Now, theoretically, you may actually encounter a different problem. Let's imagine that you have an enterprise taxonomy that has enumerated all the different types of fruit. Fruit has the children of apple, orange, and banana. But you run auto-categorization and you see that documents about the iPhone, MacBook Air, and AirPods have all been labeled as being about apples and by extension about fruit. Now you need to write a negative context rule to help your machine tagger understand that such documents should not be labeled as being about apples, the fruit, as these are actually about Apple, the company, and its technology products. Of course, this is a very simple example, but I hope it's helpful to bring the human in the loop process to life a little bit and understand this iteration between annotation review and taxonomy enrichment back to annotation review. Of course, to complement this detailed annotations and document level review, we also need to look at some macro measures of quality. These are going to be your signposts for improving tagger performance, or essentially your measurement of better correspondence over time between machine annotations and the human classification of the same document. For this, Knowledge Studio offers a few standard metrics of quality measurement. In absolute counts, you can measure true positives, and false negatives. And then these raw counts can also calculate recall, precision, an F1 score, or a Jacquard index. Which of these metrics or combination of metrics is right for your auto-categorization process will largely depend on your enterprise's goals and the desired business outcomes. You will have to understand which metrics matter to you, and you'll want to understand how your current process is performing against those metrics so you can then set reasonable thresholds or targets that you want to hit in auto-categorization. Essentially, you're going to want to define how you measure what is good and how good is good. Regardless of the metric, what we see pretty quickly with our customers is that the combination of taxonomy and tagger combined generally exceeds the performance of either taxonomy or tagger alone. So once you have your text analytics service performing in a high quality way, you're generating high quality annotations, you can then really put them to work. And as mentioned in Knowledge Studio, we store every annotation as a triple in an RDF graph database, specifically GraphDB. And this builds what we like to call a content-aware knowledge graph. This central store of taxonomic, document, and annotation data creates tremendous opportunity for an enterprise. The array of data and relationships becomes queryable in Sparkle. The results of those Sparkle queries can then be visualized or downloaded for analysis. You can specifically create similarity indexing across documents or corpora, which can then power recommendations or other similar services. And all the data stored in the database, including annotations, is exposed through API endpoints for consumption by other applications. Now, it would not be 2023 if I didn't include some mention of LLMs here. And while the focus of Graphite Knowledge Studio is an NLP-driven text analytics service, I do want to add that the process I have described can be extended or integrated with LLM technology, because Graphite Knowledge Studio accesses all its analytics services as APIs. Those LLM APIs can also be brought into the loop. An LLM overlay can be added to support functions where LLMs are a good fit, assuming that you can work around any considerations for enterprise content security or other restrictions, which is something that our customers are very much grappling with now. On this slide, I'm borrowing some of this framing from Ontotext, who have a great webinar that illustrates how knowledge graphs and LLMs can be paired for better and faster outcomes. But at a very high level, you can enhance your LLM performance with knowledge graphs by boosting LLM inputs with those knowledge graphs, augmenting retrieval, improving interpretability, or enabling the work with proprietary documents and metadata. You can also enhance your knowledge graphs with LLMs by using an LLM to generate a knowledge graph query, asking it to summarize or analyze the results of a knowledge graph query, explain a query or explain a schema, or even add embeddings from LLMs to power similarity search. LLMs could also have a role in the taxonomy workflows using their generative capabilities. LLMs could suggest alternative labels for our concept. They could help to generate definitions. They might even be able to suggest missing concepts or named entities for extraction. My message to you regarding LLM integration would be to remain focused on the human in the loop. What does that human, your colleague, need to actually accomplish for the business? What are the right technologies to scale that human knowledge with a light curatorial hand to enterprise content? This is going to help determine which specific technology should be brought into the loop for your human to manage. So just to recap here, we've covered so far how through enrichment of SCOS, controlled vocabularies can power auto-categorization of enterprise content. We've reviewed how Graphite Knowledge Studio can support non-data science and non-end users in evaluating and improving NLP text analytics services. We've shown how that transparency of the process and iterative speed can help to rapidly improve text analytics performance through rule writing. And we've discussed how you can enrich the knowledge graph with annotations to build a content-aware knowledge graph that will fuel further functionality and insight. So what are the benefits of this approach over other alternative machine learning solutions or the human tagging that I've described? Many of the benefits are anchored in the extension of your user community, bringing taxonomists, subject matter specialists, content managers, and other non-technical colleagues into the loop so that they can directly drive this process. No coding or scripting required, no data science or end resources required. The process then powers extension of these well-defined enterprise vocabularies to enterprise content with greater transparency and security than you can find in other methods, which helps to build confidence in the entire process. And the use of an NLP text analytics service can greatly reduce cost and improve quality of content labeling without requiring extensive model training or retraining, thereby supporting rapid deployment and fast iteration with minimal computational resources. And all this good work can then be consumed by downstream systems for maximum use of the content annotation. I want to thank you so much for joining me today. And I think I'll pass back to Ivan, who will help walk us through Q&A.
Thank you, Sarah, for the great presentation. We have one question by Adrian. Can you clarify if categorization relies on training data? If so, do you have a guide for how many instances are needed to train it on?
Yeah, this is a very good question, Adrian, and it's one that we actually get a lot from our customers. I think folks are really used to sort of bespoke machine learning models and have concerns about the large number of data points that need to be fed in, a lot of human management of the training process, and they also want to know how much it's cost. It costs. So actually, there is no training in the out-of-the-box Graphite Knowledge Studio product. That training has already been done with the productionized tagging services that can be activated in an API. So by the time you hit play, the annotator's ready to go, it's fully trained. And then the refinement of that analytics surface happens through rule writing, which is really about filtering the results of the tagger and directing the results of the tagger rather than retraining. And that's why the re-annotations can happen in real time with very few computational resources. When we think about how many documents you need to feed in, that's really more about what you need as an organization to feel confidence in a proof of concept sample of auto categorization. So we recommend that your document sample matches whatever scope of taxonomy you want to map against. That does not need to be thousands of documents. We've certainly done it with hundreds. I think you probably want more than a few per taxonomy concept, but we work with our customers in a proof of concept period to better define this.
Thanks, Sarah. Richard mentions that he loves your consistent, clear human in the loop theme and invents a new term, augment intelligence, standing for AI. On that topic, can you ask a simple question, but probably important for some? What document formats does the Knowledge Studio support?
Sure. Yeah. So I do want to just quickly respond to Richard's comment. Thank you. We really believe that we should empower humans to do what they do well and machines to do what they do well. And it's at that interface of augmented intelligence that I think these things really can drive value for your business. So I'm glad that that landed well. And what I love about that message actually is that it really resonates with the full spectrum of technical capabilities. People that have no understanding of machine learning and people that have deep understanding of machine learning love the idea of bringing them together in a powerful way. So Ivan, to your question about text formats, the system can run, on document formats, the system can really run on any text-based document. So we work with customers who are working with web content in any format that comes in, PDFs, PowerPoints, infographics. We will need to work with you to figure out how to extract readable text and get that into the system. And there's a number of ways that we can do that. And we and our Ontotext partners will always work with you to define a workflow that works for your business. But essentially, if your document has text, it can be fed into this. The more text, the better. Obviously, a text-based algorithm is going to perform better when it has more text to work with. It also works a lot better when the text in your document matches your taxonomy concepts. But again, that's something that we can help you figure out and work with you to iteratively improve.
Thank you. We have another 2 minutes. Can you mention some typical customers or use cases that already use the product?
Yeah. So the typical, our customer is really any enterprise where content is part of their business strategy. And I think in the modern world, that's almost everyone, right? We all have marketing content. We have web content. We have internal content that we need to drive knowledge management. We have records of past performance on projects that we need to feed into pitches. If we're responding to an RFP, we need to generate personalized content to our customers when they come to the website. So the solution really does not have any industry specifics. It can work across almost any industry. We find that our buyers are often taxonomists or ontologists that are already working in our Graphite software and want to extend the power of their taxonomies for auto categorization. We also have people coming to us for the first time because they have some problem they need to solve with scaled tagging and they want to build a taxonomy for the first time. And the use cases are largely what I described in the illustrative example at the beginning, which is people right now are relying on fairly poor performing and very expensive human tagging using their taxonomies, and they want to find a way to scale that better.
Thank you. If we can squeeze the last questions by Frederick from Findwise. Do Graphite cover the full spectrum of W3C standards as Shackle,
Sure.
OWL, and more, or is it mainly SCOS enabled?
Yeah, it's a good question, Frederick. We definitely support OWL and SCOS. We also support a lot of custom schemes. So if you do have any specific questions, I'm happy to follow up with you offline.
Thanks a lot. We are at the end of our session. Thanks everyone for watching. Thank you, Sarah, for a brilliant presentation. And yeah, see you all in the next session room.
Yes, thank you, everyone.
Thank you. Bye.